For centuries, humanity has looked up at the stars and wondered if we're alone in the universe. We've dedicated much time and money trying to determine if anyone else is out there, and recently there's been a lot of excitement in the scientific community over a newly detected object hurtling toward our solar system. For some, this was a chance to prove the possibility of alien life. In the wee hours of the morning of August 30th, 2019, engineer and amateur astronomer Gennady Borisov was scanning the horizon in Naushny, Crimea. Using a telescope with a 650mm aperture of his own design, he spotted an unknown object and posted an animation of it crossing the sky in an online Russian astronomy forum. As word spread, other astronomers around the world began scanning for the object and making their own observations. Then, the Gemini North Observatory atop Mauna Kea in Hawaii, using the Gemini Multi-Object Spectrograph instrument, was able to capture colored detail images of the object on September 9th and 10th. The William Herschel telescope in La Palma, Spain, was also able to take some images of the object. Unfortunately for alien enthusiasts, the object was declared to be a comet. It's been given the name 2I Borisov. Disappointing if you were hoping for little green men flying in a saucer, but a pretty exciting discovery for the scientific community, especially since 2I Borisov is now interstellar. What exactly does that mean? Well, first let's start with what a comet is. Many have referred to comets as dirty or cosmic snowballs. They're balls of frozen gases, rock, and dust that orbit the sun. When a comet's orbit brings it close to the sun, the ice on its surface vaporizes. It spews dust and gases to form a giant glowing head and frequently also produces a tail. Comets vary in size, but typically the nucleus or center of the comet is around 6 miles wide. The width of the coma, or the cloud that forms around the nucleus, changes size depending on how close the comet is to the sun. Scientists have studied comets with comas that are 50,000 miles wide. A comet's tail also varies in length due to how much it's being heated by the sun's radiation. Comet tails range from short to extremely long. The longest comet tail recorded to date was the tail for Comet Hyakutake, with a length of 3.3 astronomical units, or 3.3 times the distance from the Earth to the Sun, some 307 million miles. Two main types of comets orbit in our solar system. Ecliptic or short-period comets are generally defined as those having an orbital period of less than 200 years and follow the ecliptic plane, the same plane in which the planets lie. Ecliptic comets tend to be around 70 astronomical units, or roughly 70 by 93 million miles or less from the Sun. These comets are thought to have been created in the Kuiper Belt, a circumstellar disk composed of gas, dust, planetesimals, and asteroids that orbit around the Sun from beyond Neptune. A well-known ecliptic comet is Halley's Comet, which passes the Earth's vicinity about every 75 years. You or your parents may remember Halley's Comet passing the Earth in 1986, a time when Magnum PI was on American TV and shoulder pads were in style. Wait, was that really 1986 or now? Anyway, the second type of comet are nearly isotropic or long-period comets, which originated in the theoretical Oort cloud, a spherical bubble of icy cosmic debris encasing our solar system. The Oort cloud is considered theoretical because it's at the farthest edge of our solar system and we haven't yet observed it. It's thought to begin some 2,000 to 200,000 astronomical units, or 0.03 to 3.2 light-years away from the Sun. We hypothesize it exists because we've observed some of its effects on the solar system. There are likely billions of comets orbiting our Sun, many from afar in the Oort cloud, but as of July 2018, we're only aware of 6,339 of them. Back to newly discovered comet 2I Borisov. Why 2I Borisov is considered so unique is because it's interstellar, meaning that it originated outside of our solar system. It formed from cosmic material surrounding another star millions, perhaps billions of years ago, and unimaginably far away. Due to some unknown massive cosmic event, the comet is now traveling through our solar system. 2I Borisov has been determined to be interstellar because of its orbit and how fast it's moving. The comet's trajectory is extremely hyperbolic, with a wide arc that approaches from one direction and leaves in another, marking it as an object just passing through. Amazingly, the comet is traveling at a breakneck velocity of 93,000 miles per hour. That's nearly 26 miles per second. Another clue that the comet is from outside our solar system is that it's not gravitationally bound to the Sun. 2I Borisov is only the second object we've ever detected as originating outside of our solar system. The first known interstellar object was Oumuamua, which was first observed on October 19, 2017, by Canadian physicist and astronomer Robert Work using the Pan-STARRS telescope at Haleakala Observatory in Hawaii. Oumuamua means in Hawaiian scout or messenger from our distant past. Unfortunately, Oumuamua was 40 days past its perihelion, or the point that it's as close to the Sun as it was going to get. Also, it was already some 21 million miles or 0.22 AUs from Earth and headed out of our solar system when it was detected, so scientists didn't have much time to study it. Awesomely, we discovered 2I Borisov during its arrival to our solar system, which gives us much more time to observe it. Through mid-November 2019, the comet is observable with some telescopes in the northern hemisphere. It'll cross the celestial equator on November 13th and enter into the southern sky, giving astronomers and enthusiasts in Australia and other southern regions the possibility of viewing it. On December 6th, the comet will be an equal distance of about 2 AUs from the Sun and Earth. Its perihelion is December 8, 2019. While 2I Borisov will peak in brightness in mid-December unless it fades or disintegrates unexpectedly, the comet should be observable with moderate-sized telescopes until April 2020. After that, it'll only be observable with larger professional telescopes through October 2020. Since 2I Borisov began its journey so long ago to arrive in the vicinity of our solar system now, we can only speculate about the system it came from. From its entry into our solar system, the comet originated from the direction of the galactic disk of the Milky Way. Some scientists have proposed that 2I Borisov originated in Kruger 60, a binary star system composed of a pair of red dwarf stars some 13.15 light-years away from Earth. Extrapolating from the comet's orbital parameters determined so far, astronomers at the Adam Mickiewicz University in Poznan, Poland, have modeled and rewound 2I Borisov's trajectory through space, accounting for the gravitational influence of 648 star systems it passed. After a series of 10,000 simulations where researchers varied the comet's orbital parameters and Kruger 60's location and velocity, they found about 1 million years ago 2I Borisov passed just 5.7 light-years from the center of Kruger 60, moving fairly slowly, just 2.13 miles per second. Yeah, that's still very, very fast. However, that's a slow enough speed to indicate origination, rather than the comet just passing by. However, Kruger 60 results are preliminary and more simulations will be done as researchers continue to gather more data while observing 2I Borisov. So far, 2I Borisov is displaying the characteristics of a regular comet. The debate is currently raging among scientists as to how large the nucleus of the comet is. The present estimate is between 0.8 of a mile to just over 4 miles, with a tail of around 6 miles. This is in contrast to Oumuamua, which seemed more like an asteroid rather than a comet, with its odd oblong shape and unusual orbital characteristics. It lacked a coma and a tail. However, after scientists analyzed data from many different observatories, they realized that Oumuamua underwent non-gravitational acceleration. Something beside the gravity from our solar system affected the trajectory of Oumuamua. Probably the source of this acceleration was jets of gas coming off the object. This behavior is similar to how when near the Sun, ice in comets sublimates or turns into a gas without going through a liquid stage. The gas can then push the object along and usually emits large amounts of dust. However, we couldn't see the outgassing for Oumuamua. It's speculated that the comet had used up all of its dust on interstellar travels or had dust particles a size we had trouble detecting. Using telescopes, scientists have measured the light being scattered off the gases in 2I Borisov's nebulous coma. Measuring the light spectrum of 2I Borisov allows us to analyze the chemical composition of the ices in the comet that are undergoing sublimation. Knowing what chemicals are contained within the vapor of this cosmic snowball gives us a glimpse into the ancient building blocks which make up another planetary system. So far, scientists have reported the detection of cyanide in 2I Borisov, which is commonly found in regular comets born in our solar system. Instead of analyzing the light coming off of 2I Borisov, wouldn't it be easier to retrieve a sample from the comet? Scientists would love to collect material from the comet, but it's moving too fast for that. Researchers have studied whether it would be possible to intercept 2I Borisov. While it's feasible, it's pretty unlikely. Assuming that we were ready to launch immediately as of September 2019 using the latest heavy launch technology and calculating the perfect trajectory at a speed of 21.1 miles a second, a very light payload could intercept 2I Borisov in 2045. Meanwhile, the European Space Agency, or ESA, is currently building a robotic spacecraft called the Comet Interceptor, which is planned for launch in 2028. The mission is to park the spacecraft at a Sun-Earth Lagrangian point, or a point where the gravitational forces of large orbiting bodies and the centripetal force of orbital motion match to maintain a position relative to large orbiting bodies, in this case the Sun and the Earth. The Comet Interceptor will be parked at L2, which is about 930,000 miles behind Earth as viewed from the Sun. Once parked, the Comet Interceptor will wait for up to 3 years for a long-period comet to fly by at a reachable distance. If all goes well, the Comet Interceptor will deploy probes to inspect the passing comet, collecting some of the coma and sampling for gas composition, dust flux, density, magnetic fields, as well as plasma and solar wind interactions to build up a 3D profile of the region around the comet. there's a chance that the Comet Interceptor could end up inspecting an interstellar comet. It was just about 2 years between Oumuamua and 2I Borisov visiting our solar system. Scientists speculate that we receive interstellar objects visiting fairly regularly. However, up until now in history, we simply didn't have the technology to discover them, observe them, or realize that they were interstellar travelers. Not only would intercepting and studying an interstellar comet tell us a lot about another planetary system, it could provide us with proof of alien life. An interstellar comet could carry microbial or animal life capable of surviving the harsh conditions of space, traces of the dead remnants of alien life via a chemical or biosignature, or so-called technosignatures or technological artifacts in the comet debris left by aliens. So while 2I Borisov turned out not to be an alien spacecraft, studying the comet may provide us with some clues to help us determine if there is life aside from us in the universe. Do you think 2I Borisov is an important discovery? Why or why not? Let us know in the comments. Also, be sure to check out our other video. Astronomers are speechless after spotting this inside black hole. Thanks for watching, and as always, don't forget to like, share, and subscribe. See you next time.